Okay, so once again, you are most welcome. Please, we welcome you back to the channel and still thank you for the continuous support of watching our videos time and again. Okay, so we are now this time around in for item 2 of Umta physics. Please, like, still I will send my apologies, like, to you all. Like, say I took long to upload the item 2, but just like I told you, I'm a teacher by profession, and what I mean here is that I always engage myself into the facilitations and many more other activities as far as the teacher is concerned. But anyway, regardless, we move. So we have our item 2 right here. Then also, anyway, think, let's get to work. Now also, what you must know is that we've got an answer to, like, people have been sending me messages here and there, like, send us this document, send us this document, send us this, we want this paper, we want marking guides. But here we secured a platform onto which you will be able to access all our documents as far as books are concerned. And here we go. So we, yes, remind you to subscribe to the channel and then share, like, and also leave a comment. That really makes us happy by the end of the day. Okay, now still again, I've told you that we have an app where you'll be getting all our documents, but I think let's get this explained. So now, please, in this app, what you should know is that it is called the Primeline app. You download this app with this name here, and after downloading it, of course, you know the identity. After that, then after downloading it, there is some search button. You now search for this name of ours, of course, Teacher Mtanda Samir, and when you search, on the drop down list among them you'll be having this. Look at how cool this is. Now look, here we give you a physics item bank with solutions. Here we give you a geography item bank with solutions. We give you again English. Another one is entrepreneurship. We got you covered with history right there. We give you the O-level agriculture item bank. We give you the O-level CRE item bank. We are giving you the O-level biology item bank. A lot and a lot. Just look at that. But again, on this app, please, these books, we do sell them, and you realize that each book is around 25,000. But as we are in a bid of demystifying the new curriculum, we gave out an offer as Teacher Mtanda, and now Teacher Mtanda is a group of teachers actually here. So like here we chose to at least bring these materials which are at least enhanced studying. And now what we did, we gave in a promotional price of 2,000 shillings. Look at that, just 2,000 shillings. Please, it is not 20,000. Take note, it is not 20, not that. It is just 2,000 shillings. And look at how cool this is. 120 pages at your 2,000. Look how cool that is. This is 132 pages at just 2,000. Look at that. Where else? We have a lot. 130 pages again at 2,000. So on our platform, when you visit the Primeline app, then you search our name, please, all materials there are at 2,000. Of course, this price is promotional, and after around a week we shall shoot back to the original prices. So better take your time and secure these books with you. Anyway, now I know someone is asking that after paying now, how many times should we be making the payment? Please, if, say for example, you're buying this physics item bank with solutions, you only buy once. Once you buy it, it is yours forever now. Never again shall the app again ask for money for you to access the book. So for any item you buy, it is forever actually. Now, still again, after you have bought your item, how must you buy? Let's come here. How must you buy? Now somewhere, in order to buy an item, after searching, look, maybe I'll take you back here. After searching for an item, this drop down list will appear. They'll come and pick your preference. Maybe you'll click in this. When you click in that, they'll bring this. Later on, they'll have to bring you this. Now they bring this list here about paying. Now they'll ask you wallet or mobile pay. Now for you, you choose mobile what? Mobile pay. After choosing mobile pay, this will ask you, of course, you will enter the number onto which now you must be having money, some money. Mobile pay means mobile money, so you must be having some money on your mobile money, whereby after clicking in the dock you want, this will show, you choose mobile pay. After there, a message will show up on your phone, you put the pin, and then where will you find your book? Still in your app, you'll find this list here like this. Now the items you have bought will be in this area here. The items you have bought will be in this area. So you can click in my paid, that book will be there. Say for example, maybe someone has just bought what? Someone has just bought physics, like here. Maybe someone has bought maybe agriculture. After buying your agriculture, you realize that, okay, after buying your agriculture, you realize that it will show itself just right in here. When you click here on my paid, that book will show there. If you buy even 1,000 books, they'll all show there, and you can be able to access them anytime you want. Please have said you only pay once. Once you pay, that's all. Because now some people are confused and they think that maybe every time you come back you have to pay 2,000. No, this is a promotional price, 2,000 for all the books we have. And guess what? We put even very many, even the marking guides. In fact, whatever you see on this channel is there in that app. But what you do, please, I said, don't forget this. You make sure you search for this name here. You search for this name here. After downloading the Primeline app, you search for this name, Teacher Mtanda Samir. The drop-down list will show. Then you look into that and choose which doc you really want. Okay, anyway, that is, I think, really understood. Let's now go into our item 2, Umta. Now, please, before you leave this video, I know now, just like now, is there anything good in this video? Yeah. Now, what do you know about digital electronics? Have you ever heard about not gate? Have you ever heard about AND gate? Have you ever heard about OR gate? OR gate. Anyway, we call it not OR gate, but OR gate. Now, do you know anything about this? Of course, I guess no. Or maybe you know, but you need more information. Alright, good. So, in this video, we have explained the topic of digital electronics for you. Don't forget to visit the Primeline app. Then after downloading it, go in the search button, type in Teacher Mtanda Samir. You'll find all the docs there. We have all the books, all books of new curriculum at only 2,000 shillings. Don't miss out this chance. Sooner or later, we shall be taking back to original prices. So take the time and secure a book. Alright. Now, without wasting time, let's, I think, go to the work. So this is just what you're going to have in this scenario also. I just want to show you, how do people call it, a cappella, something of that sort. Now, you must just be on to this video up to when you will have to watch this explained. Anyway, without wasting time, let's go there. Now here we begin, the saying. So the saying, during a space science lesson, students learned that scientists have recently discovered a planet beyond the Earth. Oh, that's some good news. That might be capable of supporting life. A few of the planet, by the way, a few of the planets support life, and that's the only planet Earth. Anyway, this sparked their curiosity, and they became eager to learn more. As they conducted further research using textbooks and internet, they came across fascinating images, including photos of stars showing different colors and brightness, satellite images showing weather patterns and atmospheric color over specific regions of the Earth. Okay, good, we move. These discoveries led to a lively discussion. Some students believed that all the images were taken by a Hubble space telescope. Yeah, by the way, this Hubble telescope, and we shall be talking about it, no worries. While others argued that they were captured by the International Space Station, ISS. Good. Now, Hubble Space Telescope can be HST abbreviation. Confused and unable to agree, they approached you as a physics student to clarify for them the following activity. Anyway, so just know you're going to answer questions here because they have approached you. I'm talking of a person watching this video. Anyway, will you be in position to explain to them? Let's go there. Now, let's get our, okay, here we go. The same. Explaining the part A. Explain the differences in the functions and uses of the Hubble Space Telescope and the International Space Station. Is there a difference anyway? Shall I be looking into that? Okay. Why stars appear in different colors, by the way? Of course, when you look up in the sky, you see that the stars appear in different colors, orange, red, yellow, white, something of the sort. Why does that happen? Anyway, and brightness. Explain the significance of this information and explanation of the key features of a planet that would make it capable of supporting life. Yeah, we always have those X6 features which make a planet able to support life, just like our planet Earth. Okay, but see, identification and explanation of the key features of the planet that would make it capable of the supporting plant life. Plant life. Now here they're specifying plant life. Of course, you have animals and plants. Shall be stepping into that. A weather satellite per day. A weather satellite is programmed to transmit images back to Earth only under safe and useful conditions. For transmission to occur, the following logic must be satisfied. Now, when you see the word logic, just know we are in for digital. In fact, not just digital, but the mighty digital electronics. Okay, here we go. It is either daytime, input A, or or an imaging request is active, input B, and it must be currently over designated target area, input C. The satellite operator is required to design a logic circuit using only OR gate and AND gate. Now you saw that, I think, in the beginning of the video I showed you something of the sort, but I'll be explaining. And then construct a truth table showing how the circuit will behave under possible input conditions. However, he finds it as a challenge to do all this to his limited knowledge on logic gate, and seeks help from the students. Yeah, of course, you are the student, of course. I'm just assuming. Sorry if you're a teacher, but I'm just imagining that whoever is watching this video is a student. No. Are you in position to explain the OR gate and the AND gates? In fact, how signals move from the satellite on up to here on Earth. Anyway, shall be looking into that. Now, the task, here we go. The task, here we go. Here we go. The task is the same. As a physics student, okay, help your fellow students in responding to that activity. Now, which activity are these students responding to? Here we go. Meaning, you must respond to this activity A. Which activity says? Explaining the differences in the functions and uses of a Hubble Space Telescope and the International Space Station. Now, is there a difference between the Hubble Space Telescope and the International Space Station? Let's go and look into that. And anyway, plus their uses. Let's, I think, go and step into that without wasting time. Let's get there. So, let's go there. So here, all right, good. So here we are. Now, it means that before we start off with that, we must first of all look into this. Now, before we talk about the Hubble Space Telescope, we must know this brief intro. Of course, you know that as our culture, we always go pictorial first of all. Now, the same. The Hubble Space Telescope is a large space-based observatory that was launched in 1990. Yeah, by the way, that's when it was launched, and orbits the Earth. Orbits means moving around the Earth, providing clear, deeper views of the universe than any ground-based telescope by avoiding blurring effects of the atmosphere. Okay, now here, what you must know is that the Hubble Space Telescope, this one here, it is outside the Earth. In simple terms, it is outside the Earth, and now look where it is, and this is now our Earth. It is just outside the Earth, and it is able to take clear pictures. Okay, good. I hope we are able to see that. Now the difference is this telescope here moves on its own. Then also there are no human beings here on this telescope here. Shall be looking into that. Of course, we must be seeing the differences here. Let's go and see the real work right away. So part everything. So realize that on this part we shall be saying that. All right, good. Okay, let's get some. I think here I'll get this explained. This is a scenario which you must note to the end, please. So now we are starting with the Hubble Space Telescope, or abbreviated as HST. It is a large space-based observatory that captures high-resolution images. We are meaning images which are very clear. In fact, if you ever seen the maps in the geography books, or just a map, a clear map, like I don't know how I can explain, but they take a photograph of a certain area, an aerial view. Of course, well, we know that we have the drones and what, but if it is more clear, then the Hubble Space Telescope can at least do that. And spectra of astronomical objects, yeah, like the stars, yeah, as galaxies, like the galaxies we see, the stars, the planets, were all taken by that Hubble Space Telescope. And okay, and others from outside the Earth's atmosphere. Yeah, so this one here, if this is our Earth, like this telescope is outside this side. That's where it is, and it orbits means that moving around the Earth, like that. Now that's the much about the Hubble Space Telescope. Now with that, let's look at its uses. Of course, the difference and its uses, and in the difference here you must talk about the Hubble Space Telescope, the facts about it, and then you must tell us more about the International Space Telescope, also the ISS. We'll look into it. But please, all these telescopes here are managed by NASA. NASA, which is a science research group located in the USA. Yeah, I gave you one time the definition, or rather, what NASA is in full. I gave that in one of the videos. Okay. Now, please, let's look into this. Look, first of all, the use of the Hubble Space Telescope. Now, look, we said in observing distant galaxies, of course, just when the galaxies are very far, no camera can give us a clear image of the galaxies. Galaxies, no camera can give us a clear image of stars. No camera can give us the nebulae or the first stage of the stars, all right, and the planets. Yeah, only the Hubble Space Telescope can do that for us. Then it helps us studying the age, expansion, and the structure of the universe. Yes, of course, remember, if the Earth is just here, in fact, what we call the universe is, yeah, it can help us in studying the age, expansion, and structure of the universe. Yeah, of course, remember, this telescope has taken over 30 years up in the air there. So with it, you can easily notice any changes in the universe. In fact, that's what you're meaning right here. So another is that providing data for scientific discoveries such as rate of cosmic expansion and evidence of black holes. Yes. Now remember, when in the evolution of the star, rather the star, yes, when the star is growing up, you find that somewhere we can form what called the black holes. Okay, I explained that in one of the videos. In fact, it was you can go and watch Jeb item. Was it Jeb item 2? We got this explained. No, Jeb item. In fact, we can check on Jeb, one of the items. We explained how a star was formed. Jeb examined on that. So we explained that somewhere we got to know about the black holes. Black holes. So now those pictures you will see in that video about how a star is formed were taken by the Hubble Space Telescope. If you can really look into that. So if it was not be the Hubble Space Telescope, then we would not be able to get some of those pictures there. And of course, in that video, we shall say that the sun is also a certain stage of a star. Yeah, okay, good. Now, supporting space science education through public release of images. Yes. Now, maybe we need the image of the planets. How would we get them without the Hubble Space Telescope? It will really be hard. Okay. Now, of course, I have the notes for you here. There, you can be taking the screenshots for your future revision. Okay, good. Now, that's about the Hubble Space Telescope. What about the International Space Telescope? What about that? What about that? Let's go for that. Okay. All right, good. Let's go here. All right, so you want to look into that. So the International Space Telescope. Now here also, just like we said, we always go pictorial. Look at this. We're saying now. Remember, we have said about the Hubble Space Telescope. With it, does not allow human beings to be on it. Now, when we talk about the International Space Station, ISS, we say it's a permanently crewed. Now, crewed means people are there. When people board a plane, we can call that a crew. By the way, like this one here is a crew. So, it's a crewed, permanently crewed collaborative orbiting laboratory for scientific research in the low Earth orbit. So, this one here is launched up in the sky, and it moves around, but in it there are always people in there. But these people here work in shifts. Like you're seeing these people here, they can go there with enough food and they can stay there for around 3 months, come back, and the other people go there, meaning that it is permanently crewed, meaning that there are always people there, but they work in shifts. Others go down on Earth as others come back to at least navigate and see. In fact, this one also has the same importance like the Hubble Space Telescope, but it is the only difference here is that this one is run by human beings, while the Hubble Space Telescope is just running automatically. No human being is there. Okay, operated by a partnership of NASA or US. Okay, yeah, NASA. I talked about this. NASA located in the US, the Roscosmos, the one in Russia, the ESA, which is in Europe, the JAXA, which is in Japan, the CSA, which is in Canada, launched in part starting in 1998. So this was launched in 1998. If you can really look into that, about 30 years ago or 29 years. It serves as a unique research platform for studies. So this one is more like, I know at school you have a laboratory. So this is also a laboratory which is located up in the air there. It's a laboratory. Yeah, that's what we call the International Space Telescope, or rather station. Okay. Now, okay, supporting a continuous human presence in space over 2 decades. Yeah, so it has worked a total of 20 years. Of course, if you count from 1998 up to 2025, those are almost 2 decades, or a decade has 10 years. So around 10 years, 20 years plus. So I think I've seen the difference. It supports human life, okay, human presence, while the Hubble Space Telescope doesn't really do that. Now, Hubble is the name of a scientist who invented that telescope right there. So let's get this into details. In fact, let's get there. Let's get this into details. Now you shall say. You can now say that the International Space Station, the ISS, we try to explain it. So, okay, it is a large habitat spacecraft that orbits the Earth. Habitable, large habitable, meaning that human beings can stay there. I showed you that in the pic. Serving as a laboratory, living in the space for astronauts. Yeah, that really looks cool. I wish someday maybe one of us here, you who is watching the video, maybe you can also get a chance of getting there. After all, you're in for physics, which you can at least advance in it, and maybe someday you can be in the US to at least get a chance and land on the ISS. It has human crews and work on board for months. Yeah, I explained that. The ISS focuses on experiments that require humans and continuous monitoring, not deep space imaging like HST. Yeah, with it can take clear images. In fact, it can take images, but not as clear as Hubble Space Telescope. In fact, as far as images are concerned, the best device is the Hubble Space Telescope. Okay. Others are just examples. Okay, it is placed in the low orbit. Low orbit, meaning that if this is the Earth, like this, okay, this now what we call an orbit is the space around the Earth like this. The space around the Earth like this. Let me use this. Now, if this is your Earth, that telescope, they can put it in this orbit just near the Earth. Now, the Hubble telescope can be even this side. I think that, meaning that now, the more it goes this side, the more it cannot support human life. Now, in this orbit here, which is near the Earth, it will be able to support human beings to stay on it. And far away from there, they can end up dying, by the way. Okay. Now, that's what we're meaning just right here. So it shows the image of the Earth's surface, weather systems, satellites, astronaut shot photograph, looking at our planet. Now here, it is the astronauts who take the photographs, while with the Hubble telescope, it takes the photographs by itself, actually. Okay. Let's, I think, proceed. Now, uses. Of course, you must as well think about the uses. Now, remember, with the Hubble Space Telescope, we say that it's used in taking the clear images, knowing the expansion and the structure of the universe, knowing the, okay, it enhances research in science world because it gives us clear images explaining theories like formation of a star, which later gives us what we call the black hole. Now I want to look into this. Okay, we want to look into this. The saying provides a base for Earth observation and environment. Yes, it's a laboratory which is up in the air, so people, the crew on that, okay, on that satellite, you realize that they'll be able to view the Earth very well, and they'll monitor very many things. Conduct experiment in microgravity across science fields. Yes. Now, of course, you can carry out experiment on micro, means very small, or something you can't see. Of course, you know the gravity is just felt. You can't really see that. So, test life support system and space technologies for future missions to the moon and Mars. Now, of course, it is in this ISS that we were able to know that, okay, on planet Mars, no life can survive there. On planet Jupiter, no life can survive there. On planet Mercury, no life can be supported right there, and it's very risky going to any of those planets, by the way. Okay, now let's see. I think proceed. Still again about the importance of the International Space Telescope. Here we say, now it also serves as an international platform for different space agencies such that NASA, yeah, NASA, of course, you all know about NASA. All what NASA brings, they use some of the things here. Like you heard of, there was that theory back then where they said that there was going to be a big stone coming up this in the sky there, which was to hit the earth in a certain period of time, they speculated, which later didn't happen. Of course, that is all about NASA, and they only be able to get that news, which was a bit heartbreaking, through the International Space Station, which is the laboratory up in the air right away. And now this marks the end of part A. We have gotten part of the question answered. Like say, here, part of the question which wanted us to explain the differences between the functions and the differences, explaining the differences in the functions and uses of the Hubble Space Telescope and the International Space Station. I've clarified one difference you can know is that Hubble Space Telescope runs on its own, no human beings there. With ISS, it's a laboratory which supports human life, and human beings are always there on a monthly basis, and they do this interchangeably. So part A has been answered. Let's go to part B. They're saying why stars appear in different colors and brightness. We shall explain this first of all, and we have to also explain the significance of this information, then explanation of the key features of the planet that would make it capable of supporting life. Those are three things in one. Part B. Be there and let's go in for it. So let's get there. Now to begin with, let's start off. So again, in green we remind you of what the question was talking about. So like why stars appear in different colors and brightness. Now let's get that answered very fast. Let's get that answered very fast. Let's get that answered very fast. So he said that stars appear in different colors because they have different surface temperatures. Yeah, you all know. Like maybe think about charcoal. The charcoal we use for cooking. The charcoal. When charcoal is cold, what is the color? And okay, when charcoal is hot, what is the color? By the way, when charcoal is hot, it will be red. You can see that. When charcoal is cold, it will be black. Now, the difference, you realize that. Okay, so you realize that this black color here, when cold, and red color when hot, can also be a reason, at least for us to be able to understand why stars shine brightly and in different colors in simple terms. Like here they're saying, okay, stars appear in different colors because they have different temperatures. Yes, coldness, that's low temperature, this high temperature, difference in temperature. So hotter stars look blue, by the way, or white. So a star which is hot looks blue or white. You can look into that. Then why cool stars look orange or red. So right away after watching this video, maybe you can look up in the sky if there are stars there. If you see one which is blue, you just know it is hot. Once you see one which is white, you just know it is hot still. If you see one which is orange or red, just know it is cold. Alright, good. So stars appear with different brightness because some are closer to us, some are far away, and some give more light than others. Yes, of course, there's some stars which are near to us and others which are far away. Of course, we are looking at an experiment whereby, look at a torch. If this is your face right here, and someone is holding a torch just right in your face, near here, and shining the same magnitude, then also another torch at a far distance like this, which one will be brighter, torch A or torch B? You realize that torch A will be brighter. Why? It is near to you, while torch B will be a bit dimmer because it's far away from you. Same to stars. Stars which are near give more light compared to stars which are very far away. Then also think about this. Still again, shall bring back your face right here. Now if I flash in your eyes using the torch which is on the phone, then also the security torches, the one used by security personnel, what will you see there? This one with the torch, the security torches will be shining brighter compared to the torch one which is on your phone. So it means that the torch, security torch, produces more light compared to this torch one which is on your phone. And of course we have that part covered. Now still in this area, they also wanted us to explain this in green. I wrote it for you in green. So they're saying that explain the significance of this information and explanation of the key features of a planet that would make it capable of supporting life. Now this information you have right here, is it even useful? That is the significance of that information. Then also we must give key features of a planet that would make it capable of supporting life. Like, why is it that among the 9 planets we have, Earth, Jupiter, Mars, and many more. Why is it that life can only be supported on planet Earth and not any other planets? That's what you want right here. Anyway, to begin with, significance of the information which you have gotten above. So we are first of all answering this. Allow me to resolve this. So we are first of all explaining the significance of the information. Okay, now one, it helps people enjoy and understand the beauty of the night sky. Yeah, just imagine you looking up in the sky and you really know that once you see some blue or white color, that is a hot star, and when you see some orange and red color, that is some cool star. Yeah, indeed. Here, it helps people enjoy and understand the beauty of the night sky. Great. It also helps in to explain why some stars look red or blue. Yeah, that information is very, very great. Okay, next, the color and brightness tell the scientists the temperature, size, and distance, composition on each stage of a star. Yes, by the way, the color, the brightness can tell we can know the temperature. Like say if you see blue, you just know, oh, that star is too hot, maybe. Then also the distance, like brightness. If it is dimmer, then you can assume it is very far. If it is brighter, you can assume it is very near. You can look at that. Okay, next, it helps in studying how stars form, live, and die. Yes, by the way, this information here, like the hottest stage of a star. Okay, the hottest stage of a star, like we told you that the sun is a star at a certain stage, which is the hottest. If you can look into that, but you can only get that information if we really study the behavior of a star. Okay, let's do the thing. This information also helps in searching for habitable worlds. Yes, now imagine these are planets, these are planets, these are planets, and this planet is near the stars. These are the stars, but you know that where the stars are, okay, you know that the stars are very far away from us. Now you really know that the more you move nearer to the stars, based on these colors, blue or white, we tell that the stars are very hot, so that can support human life anyway. All right, so I have these notes for you. It is a bit okay. All right, good. So I think let's proceed. Okay, good. I've gotten this explained. So studying the science of the star can help us to know habitable worlds, like which planets can we really live in. All right. Still again, we are moving forward, like to find another part. Let's go back to the question, part C. Now part C is saying, identification and explanation of the key features of a planet that would make it capable of supporting plant life. Now, how is a planet able to support plant life? Now, you must be knowing which conditions on Earth support plant life. Now, those conditions there will be the ones which we need on even other planets. Like, say, we have to explain those conditions just right here. And without wasting time, let's get there. Now, here we are still. We are now trying to explain. In green is a reflection of what we have in the question, a simple reminder, because we can't keep referring back. So they say that the key features of a plant that would make it capable of supporting plant life. Okay, now any planet must be having liquid water. Yep, you must really figure out on that. So it must be having liquid water. Yes. Now, of course, I'll get that explained maybe. Okay, so I think let's start off. Okay, good. Now you all know that some planets have low temperatures to an extent that the water, in fact, we can't have any liquid, but you can just have ice only. And you find that the planets need water, liquid water, for them to carry out some processes. Now here, the ice cannot support those processes to continue. Like, say for example, the planets far away from the star have water in liquid form, okay, which can support life, hence habitable. Yes, while planets near the stars have its water frozen. Yeah, I told you that, or boiled away. Now there's some planets which are very hot, like say for example planet Jupiter. Jupiter is very hot. Jupiter is very hot, by the way. So there, the water will be boiled away and will be in vapor form. Then some planets are very cold, like say for example Neptune. Neptune is very cold, so there the water will be frozen, more like in ice format. That can support plant life. So, and in solid form anyway, from solid form, this is the form, please SP your form. or gaseous form, as this cannot support plant life. Yes, if water is boiling, that will kill, we make the plant wither. If we have frozen ice, the plant will be able to receive the water in liquid form, hence it will not be able to, okay, carry out some processes. Okay, good. Next, now this one, the point here is the liquid water. So any planet which can support plant life must have liquid water. The next, it must have suitable atmosphere. Yes, again, Jupiter is among the hottest planets, meaning if it is too hot, it cannot really facilitate plant life. Anyway, we say is one with gases like oxygen, which supports animal life. Yes, now remember, much as Jupiter is very hot, just know that in Jupiter we only have helium as a form of air. We don't have oxygen there, and of course you know that for plants to live they need oxygen, but on planets like Jupiter we have helium atmosphere which can support plant life. Okay, so must have oxygen which supports animal life, and carbon dioxide which supports plant life, and one that can protect life from harmful radiations. Yes, by the way, now you realize that here, since we don't have oxygen and carbon dioxide in there like a planet Jupiter, then it cannot support plant life. Next, moderate temperature. Still again, I said the Earth has got a moderate temperature. Meanwhile, Jupiter has the hottest temperature ever, which can just wither off or dry off the plants if at all they try to. Or if you try to plant them there, even if you take a potted plant there, it will just dry in minutes. So temperature should not be too hot or too cold. Neptune is very cold, Jupiter is very hot. So too cold, too hot, not all that required on a plant, allowing living things to survive and grow. Yeah, of course. Can you really bear a very hot temperature? You can't really bear that. Okay. Now next, you say energy source. Like say for example, life needs energy, usually from the sunlight. Yeah, there are some planets which don't receive sunlight, or if they receive sunlight, they receive direct rays from the sun, which are very hot. So sunlight or chemical reactions to fuel growth and activity. Yeah, some planets like Neptune don't really receive the good sunlight. Anyway, protection from the space dangers. Of course, now space dangers are meaning if you go on planet Jupiter, I explained this in one of the revision items on our channel here. Planet Jupiter, with it, once you go on planet Jupiter, what would happen to you would be this. Imagine this is our tomato. This is our tomato. Then get this tomato, put it on the ground and step on it at once. Of course, I know you guess what can happen there. That's what can happen to you if you go to planet Jupiter. You'll just be crushed into pieces. Of course, due to too much pressure. Okay. Now, that's what we mean here. That's what we're meaning here, that the protection from the space dangers. Yes, thick atmosphere helps shield life from harmful solar winds and meteoroids. Meteoroids, those are the big stones they used to say that they were going to come from up in the sky and fall on Earth. They were calling that big ice particles coming to fall down. We call them I'm reading it as meteoroids, but I don't know how you pronounce it, but that's not what we mean by just that. Okay, and that, let's still move on. That marks part C of our question. Let's go to the last one, the mighty digital electronics. And of course, I know you have waited for so long. Just endure for the next 3 minutes. We shall get this done. Okay, good. Now, here we are, part D. That's saying a weather satellite is programmed to transmit images back to Earth. Okay, only under a safe and useful condition. Good. For transmission to occur, the following logic must be satisfied. Okay, it is either daytime, which is input A, or imaging request is active, input B, and it must be currently over a designated detected area, which is input C. Now, how many inputs are we having here? Look at this. In digital electronics, inputs matter a lot. Look, we have input A, if you can really see that, 1. We have input B, that is second input, and input C. Those are the 3 inputs we have right here. Okay, the satellite operator is required to design a logic circuit using the OR gate and the AND gate. Now, meaning that here when you are beginning, this is how the OR gate looks like. The OR gate looks like this, like that. Now if this is the OR gate, in fact, to begin with, we have this input A and input B like this. Now I'll put them on the OR gate like this, like that, whereby this is our input A and our input B. Okay, good, let's move on. Okay, now we move the same circuit operator must OR gate and AND gate, and then construct a truth table. Shall be looking into that, showing how the circuit will behave under possible input conditions. However, he finds it as a challenge to do all this. To his limited knowledge on logic gate, and seeks help from students. Now we must help out this man here. Like, maybe allow me go back. Like, we have the OR gate, the AND gate, the OR gate and AND gate. So we are beginning with the OR gate, which we have here, OR gate. Now we must connect the OR gate. In front it must be like that. Say for example, that's how it goes. Now this OR gate here must be connected down. First you have to connect it in this format to the AND gate. AND gate shape is always like this. That's how the AND gate, this is OR gate, and this is AND gate. Yes, let me write like that. AND gate like that. Now here it must give us what we call an output. Now an input, then an output. Like say for example, if you make a phone call, in fact I'll get this explained in the next part. Now A and B is via the OR gate. Why? Because here somewhere here they say, look, they have something in relation. Let's for example say that, okay, daytime input A, or imaging request is active input B, and it must be currently over the designated target. This is another input different from the A and B. Input A daytime, and input B the imaging request is active. Anyway, I don't know how I can get this explained to you, but what we do first of all, let's Gandhi understand more about digital electronics before we can step into this. Let's go there. Now to begin with, we shall start off with this story just right here. Now please, it is in this area that you have to understand that what you call the digital electronics as a topic. Maybe, you never know. I'll try to let's make it simpler on your side. Alright, good. As you're getting things ready, let's start off. Now in digital electronics, what you must know about digital electronics here. In digital electronics, okay, this is how you realize that when you talk about digital electronics, alright, this is what we mean by, say for example, transfer of data. Like say for example, how does your phone work? Okay, how do satellites be able to send images on Earth and back? That's what we call digital electronics. How do phones work? How do computers work? Like that. Now what you must bear in mind is that in digital electronics, we have three things you must know. First of all, you must be knowing the NOT gate, you must be knowing the AND gate, and you must be knowing the OR gate. The shape of a NOT gate is this one, the way you see it here. The shape of AND gate is the one you see here. And the shape of the OR gate is the one you see just right there, never to change. Now, I'll use these three things to explain what digital electronics is. Now, in digital electronics, we have what we call an input. An input, like maybe you are dialing a certain number in your phone. Then you have what we call an output, the receiver at the other end. So you have an input and an output. Like whatever you put in, you expect results out. Now, what do we know about these gates? Now, a NOT gate, AND gate, and OR gate all have different operations, but you must all know that most of the computer or electronic devices operate in binary, meaning operate in zeros and ones, where for this case a zero can mean false, a one can mean true. I don't know that can really make some sense. Yeah, a zero can mean false. Now a zero also can mean, if you're talking about switches, a zero means off. Maybe if you have switched off your like say for example the street lights, like say for example in any city, during the day they are ever off, and during night they are ever on, meaning that those street lights, they have one of the gates they follow here, which is an automatic gate. So a zero means off and the one means on. If you can really look into that, that is if you are using the switches and many more. So there can may get other things which can relate to a zero. Zero can mean false or can mean off if you are dealing with a switch. One can mean true or can mean on if you are dealing with a switch. Okay, right. So now in the night, about the street lights, it is a 1. Why? The lights are working, they are on. During the day it is a 0. I don't think I can really look into that. Okay, now let's start off now. But if you got 0 1, this is binary. It works in binary, but you all know that binary simply means base 2, and in base 2 you have digits like 0 and 1. We don't have 2 in base 2. So first of all, bear that in mind, that digital electronics works on base 2 or a binary system, and the same way the computers operate in the same format. Now what you must think about this is that let's talk about a NOT gate. Now about a NOT gate here, now we talk about base 2. What must you know is that how do we put the input? How do we put the input? And the input, how do you put the input? The input is put basing on this. The input is placed basing on this. We use the tools. We use the tools. We use the tools. We use the tools. Like say for example, 2 power 0, 2 power 1, 2 power 2, 2 power 3. Now this means that only one input. Here there are two. Okay. Here there are 2 inputs. Here there are 3 inputs, and here there are 4. But as far as our level is concerned, we shall be ending on 3 inputs, like that. Now let's look at the NOT gate. Now this NOT gate in particular, what you must know is that it behaves like an inverter. In fact, this NOT gate here is an inverter. Or it gives what we call, NOT gate gives what we call the opposite. Like say for example, if you put here, now look here, remember we are talking about the zeros and ones. Now if you switch on any switch right here at A, the other side it will be off. That's what we mean by an inverter. It gives the opposite. The opposite of on is off, like that. So that's what we mean. Now this one is an input, an output. This one is input. Now if you put here 1, this side you shall get a 0, and if you put here 0, this side you shall get a what? A 1. I don't know if you can see that. That's how a NOT gate works in simple terms. Now what I'm meaning here is that we come back to this. Now look at this. How many inputs are we having? We have only A, which A falls in this category here. Falls in this category here. If the 2 power 0. 2 power 0. Why 2 power 0? Is because now 2 power 0 is what? Is a 1. Meaning that a 2 power 0 means that is a what? It is a 1. But the whole story must start with 0. Now 1 means what? 1 means that you put 1 0 and a 1, again a 0 and a 1, again a 0 and a 1, again a 0 and a 1. That's what we mean by 1. Meaning that because we are using zeros and 1, so 1 must appear at a time. So 0 1 0 1 0 1, like that. Now still again, allow me move this shift 2. Now here what happens is that NOT gate, here we get the opposite. Here we shall get a what? A 1. Here we shall get a what? A 0. Now what I'm doing here is a truth table. This one here is the truth table for a NOT gate. This one here is the truth table for a NOT gate. When you have a 0 here, you get a 1. Opposite. When you have a 1, you get a 0. When you have a 0, you get a 1. When you have a 1, you get a 0. When you have a 0, you get a 1. When you have a 1, you get a 0. So this one is the truth table for a NOT gate. The hint is that it is an inverter or gives an opposite, like that. And of course, if you think about that, you realize that this one here gives us the opposite in simple terms. Okay, now that is it. Okay, another thing is that let's now come and know much about the AND gate. Now I've explained the NOT gate. Let's come to the AND gate. Another. Okay, now let's go to the AND gate. Now in the AND gate, what you must know is that this one in the AND gate, it can welcome very many functions. Like for here I have 2 functions here, rather 2 inputs. Input A, input B, and this one is there is the output. Now what must you know about the AND gate? What must you know about the AND gate around of this? Now I told you that for any stuff they give you, you must straight away come forward and give us what they are trying to refer to here. Like say for example, we shall need the truth table for each. And how shall we get a truth table here for this? Now input, how many inputs are here? There are 2. 1 like that. And if there are 2, then you come back to this, you put 2 and 2 like that. Then give powers, you have a power 0 and have a power 1. Okay, let's summarize. What will be the final answer? A number to power 0 is a what? A 1. A number to power 1 is a what? Is a 2. Like that. Now it means that for the first input, this one here, we are going to go with 1. And the second input, you're going to go with 2. Now what am I meaning by this? 2 means that when you're start with a 0, but write 2 zeros. From there, remember we deal with zeros and ones. After that, put 2 ones. So 2 zeros, 2 ones. Then again repeat the process. 2 zeros, 2 ones. I hope you can be able to see that. Then in input B, this one here, input B here, what we're going to say? In input B, we're going to come and put this, like this one has a 1. Has 1. That's what you're meaning. It has 1. Now if it has 1, it means what? 1 means that 1 0, a 1. Again a 0, a 1. A 0, a 1. A 0, a 1. That's how it appears in simple terms. I don't know if they are trying to make a follow-up here. So this is how it looks like. This is how it looks like. Now, after putting these inputs, you put them using this logic I've given you up here of the 2 power. After that, now, what should we know about the AND gate? With AND gates, to get the product, you can just multiply. Now this one here is the Boolean expression. That to get the product or to get the output of the AND gate, you must multiply or dot the 2 values. Like say for example, let's try 0 times 0, you get a what? A 0. That's the output. Then a 0 times 1, you get a what? A 0. Very good. And a 1 times 0, you get a what? A 0. Very good. And a 1 times 1, you get a what? A 1. Okay. 0 times 0, you get a 0. And a 0 times 1, you shall get a 0. And 1 times 0, we shall get a 0. And 1 times 1, we shall get a 1. Now, which real life example can we really associate or locate as far as these AND gates are concerned? Now, with AND gates, you can think about, with AND gates, it works with what you call a series circuit. A series circuit. Like say for example, if you have a circuit like this, those are switches. Like this, you have our bulb right here, like this, connected to dry cells right here, back there. Now, this is switch A, switch B. Now, what are they meaning in this area? They are meaning that if switch A, now a product, this product here is where you have our bulb. Like we are looking at this diagram. Now, it means that when switch A and switch B, which are in series, are all off. Remember, 0 means off. By the way, I told you 0 can mean off and 1 can mean on. When 2 switches are off, then even the product, the bulb won't give light. So you can see that here. Switch A is off and switch B is off, even the bulb will be off. If you can see that. Then next, if switch A is on and switch B is, rather if switch A is off and switch B is on, of course, look, even when you switch on switch B, they are in series, current won't be able to reach this other side. So current from the cells this side won't be able to reach B, so the bulb will be off. Again, if switch A is on and switch B is off, you switch on A and B is off in series, then no light will be given out in the bulb. Again, what if when switch A is on and switch B is on, switch A is on and switch B is on, the bulb will give light. I don't know if you can see that. That's the relationship we are trying to bring about. Finally, let's now go to the AND gate. The AND gate here, to get a product, the Boolean expression is add. You add what you have right here. Remember here, we multiplied. For NOT gate, we had only 1, which gives, NOT gate gives opposite. AND gate, you multiply the products. You multiply the inputs to get a product, to get the output. In the OR gate, this one is OR gate, we multiply, we add the products, we add the inputs to get the output. Okay, let's start off. Still again, it repeat this process here, like we shall have 0, because it has two inputs, 0 0 1 1 0 0 1 1. Again here, which goes with the 1, I explained that it is a 0. We begin with a 0 1 0 1 0 1 0 and 1, like that. But here I must add. Except for example, 0 plus 0, we get a 0. 0 plus 1, we shall get a 1. A 1 plus 0, we shall get a 1. A 1 plus 1. Now here we shall get a 2. But since we deal with the base 2, and we don't have a 2, so you divide this, you get what? when you divide this, what are you going to have in the long run? By the way, when you divide this, here you can't write that, but I think it will give us a 1. Of course, it's either 0 or any other number, so we shall write here 1. Now 0 times plus 0 will give us a 0, a 0 plus 1 will give us a 1, a 1 plus 0 will give us a 1, and finally, I don't know if you have here, but I hope you have gotten my point. And now, an example of the OR gate. An example of OR gate is the parallel circuit. A parallel circuit. Like, say an example I'll give here. If you have this is our switch, like that, and this is another switch, like that. Okay, all connected down, all connected down. Here we have our cell, like this. Okay, I think I should have this topic explained. Then here we have our bulb. This is our bulb right here. Now, if this is our A and this is our B, they're all in parallel. Now let's look into this. Part A. What if when we switch off switch A and also we switch off switch B, when the switches are open like that, will the bulb give light? No. So off, off, bulb will be off. Good. How about here? When switch A is on, is off, but switch B is on. When you close switch B, current will come and pass through this and the bulb will give light. So switch, in fact, if one of the switches is on, then light will be given, like you can see here, in a parallel combination. I hope that will make some bit of sense. Then allow me to clear this first of all. I now have explained now what we mean by digital electronics. And after that, let's now go back to our question. In our question, they gave us an OR gate and they gave us an AND gate. Not must you know, AND gate we multiply, OR gate we add. Let's now go to the real question and we get that truth table straight away. Okay, good. So realize that this now on the truth table, we need to get our truth table, but still this shall need the, okay, wait, what I did give you here was the logic circuit. Let's first of all do the logic circuit, and that's how it must appear. The logic circuit about OR gate and AND gate. The logic circuit about AND gate and OR gates. Trying to get one here at least. Trying to get it sketched. Trying to get the picture. Anyway, there we are. And that's our AND gate. Trying to label, that's A, that's B, okay, that's C, and that's D. Now, I told you about the OR gate. Like, what you must know is that once I have two inputs here about the OR gate, what do we do about the OR gate? I said that with OR gate, we simply add. So here, the product will be A plus B. If you can really see that. Now, this whole product you're seeing here will come at this level here as A plus what? B. Then this C will also come around here. But what does AND gate do? AND gate multiplies. So it means that it will be the A plus B dot C. Dot means they're multiplying. So that's what you're going to have in the long run. A combination of the AND gate and the OR gate. Okay, so have A plus B. Then instead we have A plus B dot C. That is it. Now how we going to perform the truth table? I told you the truth table, how we go about it. Now in the truth table, sorry, let's I think it here. So in the truth table, this is how we ended. But before we start, how many inputs are we having here? How many inputs are we having here, by the way? How many inputs are we having here? Like, I mean, how many inputs are we having here? Look at this. Allow me explain from here. We have how many inputs? We have this input, we have this input, and we have this input in that order. But this must come first. So the input A, input B, and input C. Those are inputs. Then D is the output. So the output is D, like that. Now what must you know is that you give power. This is 2, 2, 2, like that. This is what? Power 0, power 1, power 2. When you power 2, how much will you get? You shall get a 4. Allow me to write a 4. I'll explain what that 4 will do. 2 power 1 shall get what? A 2. And 2 power 0 shall get what? A 1. Now what does that mean? That 4 means that when you're starting, start with zeros, 4 zeros. Then everything must be in 4s. Remember, we use zeros and 1s. So after zeros, you go with 1. So 1, 1, 1, 1. I think that. So 4 zeros, 4 1s. That's what we mean. This 2 means what? 2 zeros and 2 1s. Then again repeat, 2 zeros and 2 1s. That is it. This one means what? A 0 and a 1. They must appear 1. A 0 and a 1. A 0 and a 1. That's how we shall get a truth table for 3 inputs. Okay, and with that I think let's get back to the table which had originally. So this is our truth table, and it mark the end of this question. It has been very long, but at least I know we have at least managed to get it summarized. Please, if you have not understood what digital electronics is, I'll have it as a topic explained. You note this has been just as a by the way, and I had to really bring out the whole science so that you can understand. I've tried my level best to at least make you understand the shortest time possible, but sooner or later shall be adding or say uploading more work on digital electronics. Okay, good. Please remind you that you go and visit and download the Primeline app. Then in there search for Teacher Mtanda Samuel. We have books of new curriculum for all subjects, and as of now market price is 2,000 shillings. I know you're just surprised. 2,000 shillings, but sooner or later we shall be changing the prices for a reason. We are giving back to community, so take your time. You have 1 week. Promotional price 2,000 shillings, a book which is worth 120 pages. After that promotion, we shall shoot back to normal prices, which will be around 25,000. Take the chance, download. Okay, so I think let's get back to work now. What do you mean here? What do you mean here? What do we really mean here? Now I told you that since you have 3 inputs, like say for example, okay, since we have 3 inputs, then like say for example I have input A, input B, and input C, then output D, which you shall need later on. Now I explained this one. When I put 2, I will repeat myself, 2 and again 2. Give powers 0, power 1, power 2. 2 power 2 get a what? A 4. 2 power 1 get a what? A 2. 2 power 0 get a what? A 1. Now this one 4 means that start with 0 and write 4 of them. 0, 0, 0. Then 4. But remember, write in zeros and 1. So after zeros you got 1. So 1, 1, 1, 1. There should be 4. So 1, 2, 3, 4. That's how you go about the input. Now the input B, it has 2. Mean that 2 zeros, 1, 1, 2 ones, 2 zeros, 2 ones. What about 1? 1 means what? A 0 and a 1. It appears once. 0 and a 1. A 0 and a 1. A 0 and a 1. Like that. We are getting Umta item 2 solved with ease. Okay, so we start. I've explained, and I hope you now know how and why that one is appearing like that. I've also explained how this one, why that one is appearing in that format, and I've also explained why this one is appearing like that. Okay, straight away. Now trouble comes. Remember, for this I'll remind you again, I'll still remind you again. Like say for example, this one here, A and B were in. This A and B, alarm right here, A and B, these two here, they were in for what? They were in for the OR gate. OR gate. And then what do we do in the OR gate? Remember, in the OR gate, okay, we do what? We add in the OR gate. Then from there, the B and C after there. Now this C alone had the AND gate. And what does AND gate do? AND gate multiplies. So what I'm going to do here, this and this you will add. This and this you will add. This and this you will add. Please, you are seeing how we can get the table. This and this you will add. 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 So here we add. Then from there, any answer you have there, to move to this level here, you must multiply to give us the answer there. Like say for example, we shall say 0 plus 0, you get a what? You get a 0. Okay, 0 plus 0, you get a 0. 1 plus 0, you get a 1. 0 plus 1, you get a 1. 1 plus 0, you get a 1. And the 1 plus 0 again, you get a 1. And the 1 plus 1, you get a 2. But I told you here you can harmonize and divide this, which later comes back to what? You can harmonize that. Whenever you have a 2, you can harmonize that. So long as it's a counting number, since you don't have 2 in the base 2, you can harmonize that into a 1 like you have it right there. Then 1 plus 1 is 2, but you harmonize it back to a 1. So this one also will give us, maybe we can just say a 1 even here. it will also give us a 1, like that. Now these are the answers after adding. Now what you do, these answers here, multiply them. Why multiplying? Because it's the AND gate. So 0 times 0, you get a what? You get a 0. Then also come to this, a 0 times 1, you get a what? You get a 0. Then a 1 times 0, again you get a 0. Then a 1 times 1, you get a 1. I hope you can now be able to see that. Then, okay, allow me. Okay, now a 1 times 0, again you get a what? A 0. Then a 0 times 1, you get a 0. Then, oh sorry, this is it. Remember, I have here 1. 1 times 1 will give us a 1. Then 1 times 0 will give us a 0. And the 1 times 1 will give us a 1. And that's what we call a truth table in simple terms. Alright, good. Now, I've tried to at least get that explained, but sooner or later I shall be uploading this topic here on the channel. But like I told you, there are also teachers by profession who always get involved in other activities away from the YouTube channel. Anyway, thank you for watching. Please download the Primeline app. Download the Primeline app. Like, I'm reminding you to download the Primeline app so that you can enjoy a lot more of our things we upload there. Thank you. Next time.